Hello and welcome to today's European SharePoint Office 365 and Azure Community webinar. My name is Shane and I'm delighted to be joined by Thomas Fouchen, MVP, MCT, Cronus Group, Belgium, who will be talking to you today about getting started with Git and GitHub for the reluctant IT pro. Remember to join in the conversation about today's webinar on Twitter. Our Twitter handle is @EuropeanSP and our hashtag is ESPC21. Don't forget to check out the Resource Center. This is updated daily with the latest blogs, ebooks, webinars, and how-to videos. Simply visit SharePointEurope.com and click the content link at the top. Check out all upcoming webinars. For example, on Wednesday, September 15th, join Martin Laplante, CEO, Icefire Studios, for Microsoft Teams translation and language features. Full details at SharePointEurope.com. We also have SharePoint Week, one unmissable week of free online SharePoint learning. This is happening from the 20th to the 24th September. Sign up today at SharePointEurope.com/SharePoint-week. Also, we have a Microsoft SharePoint tutorial extending Microsoft 365 with SharePoint Framework by Paolo Pialorsi. This can be joined on Friday, the 1st of October 2021 from 9 to 5 CEST. Book now at SharePointEurope.com/pricing. ESPC webinar series is supported by Docs42 and Pointfire. And please bear with me here for one moment as we have a short video to share with you. Any moment now.
Hey you! In the session you will see all about the great options of the Microsoft technologies. But what about generating documents in the Microsoft ecosystem? Like quotes, reports, emails, PowerPoints, and others. The challenges usually are many different data sources, an intuitive design in Microsoft Office, and of course generating the documents where the user needs them. In SharePoint, the Power Platform, Teams, or Dynamics. Docs42 can do all of it. Try now yourself.
Hi, I'm Martin from Pointfire. This year I was hoping to entice you with a booth, games, prizes, giveaways. Instead, we have this short video to show you how we make the multilingual page publishing feature even better. It's so easy, the demo only takes a few seconds.
With SharePoint's new feature, your staff still has to translate each page manually. By adding the Pointfire translator, the pages get translated automatically for your approval. Go to try.pointfire.com for a free trial or contact us for a demo.
Brilliant, super. And after the webinar, we will have a questions and answers session. Type any questions you have in the questions window. Questions will be selected and answered at the end of the presentation. This webinar will be recorded and added to the Resource Center, where you'll be notified by email when it is available. And now I'm going to pass you over to our webinar presenter, Thomas Fouchen. Hello, Thomas. Whoops, just bear with me here, Thomas. I'm just going to get you unmuted and I'll make you a presenter. So Thomas, I can see you and I can hear you.
Thank you, Shane. Thank you for the introduction. I'm going to try to share my screen. Well, that should be working now. I suppose that someone will yell if they don't see my screen. Okay,
yeah,
right.
I can see it. Take it away, Thomas.
Yeah, right. Okay, thanks. Welcome, everyone. This session is aimed at IT professionals, and in the next 60 minutes or so, I'm going to try to learn you the basics of Git and GitHub. If you're a developer or if you're someone who has been working with Git or GitHub for already quite some time, I will cover the basics mainly, so you might have seen some of these materials before, but definitely don't run away if you're a developer or someone who is seasoned in using Git and GitHub. You might still learn something, of course. Okay, on the agenda. Like I said, it's a getting started session. So the first things first, introduction to Git. Git is quite an interesting topic. It's been around for a very long time, but it's not until the last few years that I think also with the introduction or the introduction with GitHub and Microsoft embracing the whole Git and Microsoft and GitHub ecosystem that it became also in our community a lot more, a lot bigger than before. So we're going to talk about Git, what it is, what you can do with it, what the differences are between Git and other source control systems you might have used in the past. That's a gentle introduction. Next is the tools you need to get started. Git is a software product, so you need to install something on your PC. We're going to talk about the tools that you probably would want and have to install on your PC to get started with Git and GitHub. And then I'm going to demonstrate you how you can do the most basic stuff with Git, because many tutorials dive right into very specific problems or very more complex stuff. But well, you need to know the basics too. So that's what we're going to cover here. And then last and not least, I'm going to hopefully live during this webcast issue a pull request to a community repository that I want to participate in. And hopefully you can also learn then how you can contribute back to the wider community. So that's always a little bit tricky. I didn't do my sacrifice to the demo gods this morning. Well, we're going to do some contribution to a repository later on. Just a little bit about myself. I'm Thomas Vochten. I'm a technology evangelist with the Kronos Group, which is a large technology group in Belgium. I'm also a Microsoft MVP, which basically means I like talking a lot. I'm also the president of the Belgian Information Worker User Group, which is a mouthful, which is a user group in Belgium, and we organize monthly meetings around Microsoft 365 and related technologies. We also organize Collab Days Belgium. That's the event formerly known as SharePoint Saturday Belgium, and that's going on October 23rd. So in a couple of weeks, we are doing our online event together with our Dutch colleagues. If you've got any questions, like Shane mentioned, you can. There's a chat window, and after the session, we'll do a short Q&A moment. But even if you've got any additional questions afterwards, don't hesitate to contact me through Twitter, or you can even send me an email if you want to. All right, so let's get started. We've got a lot of material to cover. First, like I said, we're going to go through a few slides introducing Git, but also we need to talk about why, as an IT professional, because that was the main target of this audience, you might be interested in learning about Git, because Git is traditionally a developer tool, right? Using source control, using all these fancy command line tools that developers like. What is there for us? What is there for us IT professionals, or maybe also developers which are not used to using source control or Git in the first place? So a big question is, why would I care? Like I said, developers have many toolings, best practices, and using source control is one of those practices. Source control does not only make your own life easy, because you can protect yourself from all kinds of horrible failures if you mess up your code, or in my case, I'm an IT professional, so I use a lot of PowerShell, or if you contribute to documentation and you want to change something, you want to go back, source control all enables that. So that's one of the main reasons for me to use a source control system. And also, if you want, and we talked about that already, if you want to contribute back to the community, if you want to contribute back to open source. And open source, if I talk to IT people, they usually think, well, contributing to open source, that's not for me. That's typically for developers. And that, for the most part, that is probably true. But there is so much more that you can contribute back to the wider community, like PowerShell scripts, but also documentation. And we're going to talk about that later on in this presentation. But I think we all agree that the main the main focus or the main goal of using source control is getting out of situations like this one. Well, this is a collection of PowerShell scripts, and if you've used PowerShell before and you've maybe written some PowerShell scripts for your customers, this situation might sound very familiar probably. First things is where do you actually store your PowerShell files, or any files for that matter? I'm using PowerShell as an example now, but it's the same for every kind of file. Well, I've been storing PowerShell scripts on my PC. I've been storing PowerShell scripts on my hard drive, of course, maybe in OneDrive. I used to use Dropbox a few years ago. Well, those PowerShell scripts, they end up everywhere. I even used OneNote for a fair bit to store these scripts. The location where you store them in itself can be a problem. If you store your files on OneDrive, I know you can share them with other people, but it's not really convenient. Plus, you miss out on all of the other features of what a source control system might offer you. If you look at the screenshot here, something that is very common. So you start out with a script, you give it a certain name, and then later on you decide to change something. But well, you're never sure if you might still need the first version of the script. So well, you create a V2. And then you implement that V2 at a certain customer, you make some additional changes, you go back to the original V2, make V3, and then maybe that gets evaluated in version 4, and then you implement that version at another customer, etc., etc. You know the idea. In the end, you end up with a lot of scripts or files with all kinds of different contents, and in the end, if you end up with a lot of them like this, you don't know what to do with it, of course. And what if you want to make a change to the base functionality of the script? You might have to make this change in 25 different locations. So it's not really convenient. And it gets even worse if other people also might want to contribute to these scripts. Let's say you have a colleague who says, well, your script to do stuff is really cool, but I want to change something, but I found this new functionality. Well, you can ask them to copy the code and send it over through email and then paste it in the document, but you get the idea. That's not really convenient. That's not really what we want. So we need something else, and where SharePoint on OneDrive is the go-to system for source control, let's say for regular Office documents, code or other files might need a source control system to do so. So it's basically version control, right? You make a change, you upload that to the source control system, and you're able to go back, for example, if you want. If you make an error, or if you just want to look at the previous version of the file, source control like SharePoint or OneDrive, but for code. So that's already quite powerful. Something else is that you are able to keep different versions of your files. It's a little bit the same, but let's say if you implement a script at a customer A and then also want to keep a version that you implement at customer Z, etc., you're able to switch between these different versions quite easily. I usually in this talk I talk about code or scripts, but it's generally true for all kinds of files that you might have. Something else that you might want to keep different versions of your files, one for production, one for your staging, one for test, etc., etc. So that's also already quite powerful. You're able to go back if you messed something up, which is, for me personally, the main reason to use a source control system like Git is because we all make errors, especially me. So you want to go back to undo your change and work further. Work together with other people. That's a key aspect of using source control. As I said, if you put your script just on your personal PC or on a network drive somewhere, yeah, you can work together, but it's not all that convenient. And something else is that you might not realize in the beginning when you're using a source control system like Git is that it enables you to work on new stuff or fix bugs in your code while the, let's say, production version of that file still remains for others to use. So you don't have to make copies of a file. You can safely work in a safe place on a different version of the file, while your colleagues can just grab the original file while you keep going. So, and there are many other reasons why using a source control system, even for an IT professional or a non-developer, could come in handy. So that's quite cool. Now, throughout the years, there have been many source control systems available. There still are. Today we're talking about Git, but there are many more. I've used Team Foundation Server in the past. I've used Microsoft Visual SourceSafe a lot of time ago, luckily. And there are many more source control systems, but nowadays I think that debate has more or less settled, and most people I know are using some kind of implementation of Git. Git has been around for quite some time already. It was already around many years ago. It was created by Linus Torvalds, the same guy who created Linux. He also created Git because he needed something to control the Linux source control and to coordinate that with other developers. So that's yeah, and he named it Git, by the way, because it really reflects his personality. Git is a little bit, yeah, let's say English slang for an annoying and unpleasant person, let's say, and that really mimics his personality quite well. So he knows about himself. That's Git. So Git is a free and open source distributed version control system. All these words are really important. Free, well, it's open source itself. You don't have to pay something. You can just download it if you want. There are new versions every month almost, so that's quite cool. But the key word on this slide is distributed, and that's also what's more like sets it apart from other version control systems that you might have used in the past. For example, in Team Foundation Server or other source control systems, if you want to make a change, you have to check out certain files, which effectively disables them from being changed by other people. In Git, there is no such thing. Everyone, more or less, has the same permissions and can do the same thing with the code. And that's quite, well, that's quite important, and we will get to that, why that is so different. So the most important word on this slide is distributed. There are some key concepts that we need to talk about before we dive into some more practical details. Yeah, what about this distributed? How is that different? So, like I said, traditionally you had one version of the truth in a central system somewhere, which you could subscribe to and then make changes, publish changes, block some files from being changed by other people. But in Git, that's totally different. In Git, you have multiple locations where your code, and I'm always saying code, but can also be documentation, PowerShell, etc., where your code lives. So you might have a shared repository, so a central location where everyone agrees, and the agreeing part is important here, where everyone agrees that this is the single or the most important version of the truth of these files. But then you have different developers or people working with that information, and they all have local copies. And it's totally, well, it's connected, but it's also not connected. So that means that you can copy the whole code base to your personal PC, and you can do whatever you want with it. You do not ever have to connect it back or commit it back to the shared repository if you don't want that. It's all based on conventions and certain practices, and that's already quite critical in working with Git. So people create copies of the shared repository, and they can make changes there, and if they want, they can commit those changes back to the shared repository. And once those changes end up in the shared repository, the other people who already made copies of this software or of these files can also pull down the changes that were made by you. Now, of course, not everyone has the same permissions in this system, so it might be that certain people only have permissions to do something in the shared repository, etc., etc. But that will lead us a little bit too far, maybe. So the distributed part is really important. There is no such thing as a single version of the truth. It's only by convention that people say, well, the shared repository, that's our main repository, let's say. that will become a little bit clearer in once we get started. Something else that is different from many other source control systems is the concept of branching and merging. It allows and it encourages you to have multiple local branches for different purposes, to try out an idea, work on a certain feature, or fix a certain bug. And when you've done that work, you can merge it back into the main branch. Again, this is a convention. So in this slide, you have a master branch, a development branch, and a topic branch. Those are just labels. They don't have any specific meaning. Even master does not have a specific meaning. It's all, again, a convention, where we all agree that the main production version of the code lives in the master branch. And if I want to make some changes, I create a copy of that master branch and I give it another name, for example, topic or developer. I can make my changes, and when I think that I'm done, I can merge these changes, or I can ask someone to merge these changes back into the master. And the whole cascading system of branching and merging changes back in, that is something that is really important for you to learn if you really want to get started with Git. Also, if you want to contribute to open source projects, it's understanding this system of branching and merging is quite essential. We'll also get back to that in the demonstration. Something else that sets Git apart is that it also has the concept of a staging area. In many other source control systems, if you pull down changes and if you make changes, you need to commit all these changes at the same time back to the original repository. And with Git, that is not necessarily the case. So you can pick and choose which files you want to, which you think are okay, that you can commit back into the main copy of the code. It's called staging. Something else is that Git, it's small, it's fast. You can install it next finish on your PC, but it's also very, very, very fast. And that's also because everything you do in Git is done locally. That means there is no, well, there might be a central server where you keep the copy of the code, which also has Git installed. We'll get back to that. Yeah, there is no active connection with a central server somewhere. If you type in Git commands in your command line, that is all done locally, and because you have a local copy of the entire source control database on your system, which also makes it very robust. It uses a proprietary way of working, but it's really, really resilient. There are of course ways to mess this up if you want, but yeah, that's not really the point, right? So that's quite cool. That is that every change you make generates a unique ID, and it's using these unique identifiers that all the changes are tracked throughout the system, even in a distributed way of working. Right, it was maybe a little theoretical, and you might say, well, this is already quite something, a lot of theory, a lot of new words that I might not understand. You maybe heard about committing or merging before, but isn't Git really, isn't it really difficult? I hear it's really difficult. And I think this cartoon here really hits home, I guess. If you talk to developers who are working with Git already for quite some years, they will still say, well, Git can be very, very, very hard. And that's true to a certain extent, but the basics, getting started, working with stuff you download from the internet, working with the local Git commands. If you don't do anything fancy, if you're not working in a project with 25 other different developers all creating branches and merging them back in, which creates conflicts and stuff, can be complicated. That's true. And the cartoon basically says, okay, and what many people actually still do, although it's not really encouraged, is, okay, before you make a very specific change, you just create a copy of the files, put them somewhere else in Explorer, and then if you fail, you wipe everything away and start again. Well, it's not really meant to be used that way, of course, but I must say I'm guilty of doing that a few times already, but I'm learning. Now, a very good resource to have at hand when you are working or getting started with Git, and even if you're a more seasoned user of Git, is this website. It's maybe a little bit offensive, ohshitgit.com. It's a brilliant website. It's a very small website, which gives you a few very common mistakes or common problems that people encounter when they're using Git, and how to get away with it, and how to get revert back to what you were doing before. So it tells you how you can go back, how you can use it. Calls it the time machine, but how you can go back into time, how you can, if you, for example, committed something to the wrong branch, what you have to do, etc., etc. If you don't want to share this site with your colleagues because of the language, there is an alternative. There is dangitgit, dangitgit.com, which is a little less offensive language, and there are also localized versions in different languages if you want. So this is a really cool website. Bookmark it somewhere. You will absolutely use it and need it once you get started with Git. So we talked a little bit about Git, the basic concepts, the differences between other source control systems. But what about GitHub then? This presentation wasn't only about Git, also about GitHub. GitHub is just, and I hate when presenters use the word just, but in this case, it's just a hosted version of Git. So you might install Git on your PC, next finish, but there's also hosted Git, so that's a version, a copy of Git running in the cloud, in this case, hosted by Microsoft in GitHub. GitHub is a Microsoft website. It says on the slides it's a de facto standard. There are alternatives which also use Git in the backend, like Bitbucket, for example, or GitLab, and also Microsoft's own Azure repos, which is still there, which is still available, and it also uses Git, or it also has the option of using Git. Within the Microsoft ecosystem, almost everyone uses GitHub because GitHub is a public website, and you can, if you want to share something with the world, you can use GitHub to do so. Many open source initiatives founded by Microsoft are also on GitHub. The source control of Microsoft of many of their products is also in GitHub. Maybe not public, but you're also able to create private repositories. GitHub is the de facto standard. I think, although I know a few users who use Bitbucket. So when do we use GitHub? Remember when we talked about the distributed system or way of working of Git? GitHub is just another copy of the code that you might have locally. The main difference is, again, convention, is that we all agree that GitHub is probably, doesn't have to be that, but probably the master, where the master version of the code lives. So we all copy the code that is hosted on GitHub, copy that to our own machines to work with and to propose changes back to GitHub to contribute back. That's the idea. Right. So that was a little bit of a theory around the whole version control system. What tools do you need to work with all these fancy tools? So first of all, you need Git, which is a free download. You can just, if you Google for Git, the first link will be the download. You install that on your machine. You can also install on Windows, Linux, Mac OS, any system that you want. And then you need some kind of terminal to interact with Git. My choice of preference is Windows Terminal, and I think if you're using Windows, that you should absolutely use Windows Terminal. It's much better than the built-in PowerShell or command line tools. So have a look at Windows Terminal. And optional is Visual Studio Code. If you're not a developer, you might say, well, Visual Studio, I don't want to go there. But even if you're working with PowerShell a lot, Visual Studio Code is a fantastic editor. I used to go to Notepad++ all the time. I still do that, but nowadays Visual Studio Code is probably my editor of choice for almost everything. So that's those three tools. I absolutely encourage you to check them out and to use them. I've got a few links in the slide deck later on, which point you to a few resources where you can see how you can install those and make them how you want them to behave. Something else that not many IT professionals I talk to know about is the GitHub CLI, the command line interface. A lot of the things that we're talking about today can be done through the normal Git client, which you download from the previous slide. But GitHub also has a command line interface, GitHub CLI, that you can use to do almost everything, well, a lot of the functionalities that are available on the GitHub website themselves. So creating repositories, issuing pull requests, or looking at issues, filing bugs, stuff like that. You can all do that through the GitHub CLI. It's also free and also available for all the usual platforms. So absolutely also look at GitHub CLI. I'm also going to use that in my demonstration later on. And then from a tools perspective, and when we look at the command line, you've probably already seen stuff like this on other blog posts or talks. You can go to the Windows terminal or a command prompt or PowerShell and have a basic standard prompt, but you can also have something like this, which is, I would say, almost a necessity if you work with Git to not make mistakes. So what it does is, if you're in a command prompt inside of a Git repository on your PC, it will tell you where you are. In this case, in the screenshot, we are in the main branch, and it will also tell you when you have to do something. And that's these fancy numbers that you see, +0, -0, etc. That will tell you if you need to do something. For example, if you added a file to a repository and you did not commit it back to the central repository, stuff like that will be highlighted in the command prompt. The tool almost everyone uses to do so is called OhMyPosh, which is also free to download. And I used to have a slide with instructions on how to install this and make your prompt prettier, like this. But Scott Hanselman, well-known Microsoft celebrity, published a very nice blog article last week that I'm linking to beneath on the slide, which explains to you in much more detail than I could ever do in the 5 minutes that I can talk about this. So absolutely go to Scott Hanselman's blog to look at that, and then you can make your prompt pretty. OhMyPosh has much more functionality than just Git integration. You can use it to, I don't know, specify your battery status inside of your command prompt, and many other possibilities. So definitely look at OhMyPosh, created by another MVP, by the way. If you don't like command line tools, and using these command line tools is great for learning Git, but sometimes can be a little bit intimidating. If you want to step away from the keyboard and say, okay, I don't know what I have to do now anymore, there's also graphical user interfaces to Git and GitHub. This is a good example, GitHub Desktop, also available to you for free, made by GitHub, but it can also be used on Git repositories, which are not part of GitHub, which give you a graphical interface to interact with the files. If you want to go back to a previous version, you can do that. If you want to make changes or look at differences between files, stuff like that, which takes a few time to learn on the command prompt, you can also do that through GitHub Desktop. There are other tools like Git Kraken, I've used that before, and a few other ones that provide you with the same functionality, but this one is free and it's pretty good. So that's a GitHub Desktop. And last thing about the tooling, if you're using Visual Studio Code, by default, Visual Studio Code already has quite good integration with the Git source control system. We'll get to that in a demonstration. But if you want to augment that experience, there are some very useful extensions that you can know that I urge you to install. Git Lens, Git History, and GitHub integration for Visual Studio Code. The first one, Git Lens, gives you a line-by-line information pane on which line was changed when, by whom, stuff like that. Git History gives you better history integration inside of Visual Studio Code, and GitHub pull requests and issues enables you to not leave Visual Studio Code to create a pull request, for example, or to file an issue for a certain piece of code or text that you are working with. So definitely check those out. We've got like 25 or 30 minutes left, so it's time for a demo, I think. But before we dive into the demo itself, when you work with Git, it's you meet a lot of new words, right? So we need to talk a little bit about essential lingo. I don't have time to explain all these concepts in great detail, but I just want to give you some pointers to what you might hear about. Cloning, that's one very common one. And cloning basically means taking or downloading a repository from a certain source to your PC. That's cloning. We're going to do that in a minute. Committing means you change something and you want to push it to the source control system. You want to commit it to the source control. That's committing. Pushing means you're working on your local copy of the code and you committed it to your local copy and you want to push it back to GitHub, for example, then the command push is used. Pulling is the other way around, of course. So you're working on your local copy of the code, but in the meantime, someone else has changed something centrally in GitHub, or another colleague of you has changed something. Then you can pull those changes back into your copy, so you always stay current. Merging is merging those changes back in. With a little bit of luck, you don't have any conflicts because it's a source control system and it's Git, it's very powerful. But when you merge, well, conflicts might occur. If you both change the line, who is going to win? There are certain strategies for that which are beyond the scope of this presentation. Branching, we talked about that already. When you copy off a different branch so you can work on something specific or fix a bug or try something out, that's called branching. And then we also need to talk about forking, but we're going to do that through the demonstration. So that's those are a few. There are other concepts like stashing and stuff like that, which are very interesting. But yeah, that will lead us a little bit too far. And last but not least, there is the concept of a pull request, which is also a convention. It's not really a technical thing. Pull request is a way to ask to integrate your changes into a central repository that you might not have permission to, maybe. For example, if I change something on, let's say, a community project within GitHub, I don't have permission to that, but I want to make a change. I issue a pull request. I ask them to pull my changes into their repository. That's why it's called a pull request. Many of these things, for example, forking or the pull request, are conventions, by the way. So they're not enforced by the tooling themselves, but you're expected to work in a certain way. All right. I think it's time for a demonstration. With a little bit of luck, you're seeing a not too fancy command line prompt here. So some basic concepts. Often people will tell you, well, you can find that on GitHub, or you can find that on my GitHub repo. And then you end up, if you open the browser on github.com, on someone's profile, like mine here, and then you see different repositories. Some of these repositories have been created by the user you see here, and some of them are copies of a central repository in another place. For example, my website is here. It's private, so you can't see them when you go to my profile. But I also have a repository called with my name, Thomas Vochten, which is a special one in GitHub because this is the file, and it's a markdown file, which which contains your sip of water, which contains your about me information. So let's say this is the information you want to use. How do I create a copy of this? This is a very small repository. It's only one file, but let's say it can also be very, very, very large. So you end up at this repository, and then you have this green button here, which says code. In this case, it's not really code, but you get the idea. So what you can do then is, if you installed Git, you can copy this URL here, github.com/thomasvochten/thomasvochten.git, which is the reference to this repository. Or if you're using the GitHub CLI, a tool that I mentioned, you can just copy this command here and paste it in your editor. Let's use the first way, and let's go to our command line. This is just Windows PowerShell. So you say git clone, and then you paste in the URL. It's very It's very fast because it's a very small repository. And then you can go to this repository. If you see something fancy happen in my PowerShell prompt, is because I installed a few extra modules to help me. So we are in the Thomas Vochten repository, and you can see that immediately my prompt has changed. So it will tell me we're in the master branch, and everything is green. That means I made no changes. I don't have to do anything. I'm cool. So that works. If you ever doubt about what a certain color code means, you can always type the command git status, and then it will tell you exactly what you have to do. In this case, nothing. And so you're up to date. You don't have to do something. Everything is nothing to commit. Working tree, clean. You don't have to do anything. So that's okay. That's quite cool. Let's look at Windows Explorer. How to see how that looks in Windows Explorer. So exactly the same to Windows Explorer. There's just a folder and a file, a README file. Nothing special here. There is a hidden folder here, .git file, .git folder, sorry, which contains the actual Git source control information of your project. Do not ever mess with this information, because you will mess it up and your source control will be broken. That's also why it's hidden. That's very wide. So all changes you make, all commits, everything will end up in this folder somewhere. So okay, let's look at the information. Let's maybe change something. You can change that in different ways. You can open a file in Notepad. This is the Notepad file. I'm using the Windows 11 version, so I can do all kinds of fancy things. So this is the file inside of that repository. I opened it with Notepad. It's Markdown. It's a little bit like HTML, but simplified, and I can make changes here. Now I'm the owner of this repository, so I can do whatever I want, basically. So let's say I want to change this. Hi there. I'm not much of a developer. I want to correct this. Let's say it's a typo. I'm not much of a developer. Let's save the file and go back to the command prompt. And then when I just press enter, you will see the color. The color will be changed, and it says, "Oh, there is one. You made one change." Again, if you're unsure what you need to do a git status, and it will tell you. So we're on the master branch, so the main copy of the code, and there is a change that is not staged for commit. Two words that we already talked about. Committing means pushing your change to the source control system or making it available to source control, and staging your changes. That means that you have to choose which changes make it into the source control system and when. So first of all, you need to add the file or the change. You need to add the change to the system. So we say git add, and then that's if you change multiple files, you can always do git add star. Then everything will be committed. But now I have just one file, and then you need to commit. And committing always needs a message. Let's say small typo. And these commit messages are quite essential. You might be tempted to just put whatever, but I can assure you, if you're working with multiple people, it's really, really convenient if you actually see why people committed something. So git commit with a small message, a small typo, and then press enter. And then the color changed again. Again, if you're not sure on what to do, although the icon gives it away a little bit, git status. So we're on the branch master, but we are ahead of the origin. What is the origin? The origin is, in this case, GitHub, because we cloned our repository from GitHub. So that means that we might be able to see, for example, GC, that's get content shorthand in PowerShell. We can see that we have our change here. I'm not much of a developer, but if we go back to GitHub and we refresh the page, well, nothing has changed. Still has the original information. So what we still need to do, and that's what this one specifies, is we need to push that change back to the original repository. In this case, I can just do git push because it already knows about the connection, and then all right, it says everything is done, and it's green again. So if we now go to the website and refresh, we see, okay, the change has been committed. For every change, there is a change history. You can track all changes. So you can, for example, see here these through this GUID here that I made one change, a small typo. That was my commit message, and this is exactly what I changed. So Git is very smart. This is a very simple example of what we might do. Now, this is just one file. If you've got multiple files, it works more or less the same. You just need to add more files, commit, and then push. Now, what happens if someone else is also working on this information on another workstation or another colleague somewhere in the world? Well, they also might have a copy of this repository. Let's switch to my second tab here, which is a Linux in WSL, which effectively is more or less has the same effect as being someone else or working on a separate machine. I already have the same repository here. See, on another machine, everything is green. Perfect. So I'm on the master branch. Let's look at the README file. I did that before, but of course, it's still the old version. So whenever you're working with Git and whenever you're working with multiple people, before you start working or doing something, you always have to make sure that you're not only cloning, but from time to time that you also do a Git pull to make sure that you're working with the latest changes. So if we do Git pull, it will see that the README file has 2 changes, and it will integrate that back into my local working copy. So now we can see that I'm not much of a developer. Does PowerShell count? So I'm working with the latest version of the code. So it works both ways. If I would make a change here in my Linux machine and I would commit it back to GitHub, in my Windows machine, I would have to do a Git pull to see those changes, etc. So that's a continuous cadence of Git pull, Git push, Git commit, Git add, stuff like that. That's the usual basic way of working of with the basic Git commands. If at any time you're unsure, or if you want to look at the log, you can say do Git log, and you can see, okay, these are the different commits that we made. And there are commands to get more information or to do differences between the 2 commits, but those are the basic commands. So and it works in Linux, and it also works in Windows. So what if you have some code available? You have some or PowerShell or whatever information that you have. What if you want to upload that into a source control system? If you already know that you're going to use GitHub, you can go to GitHub, create an account, and then there is a button somewhere, if you go to repositories, to create a new repository. As something you can do, you give it a name, doesn't really matter, a description. You say if your repository is going to be public or private, and there are a few options here that you can choose, which are not that interesting right now. And then you create your repository. We can just do that now, doesn't really matter. And then it gives you some instructions on what to do next. It's code that you can really copy to your machine. So you can already clone this repository that you just created and use that on your local machine. But you can also work the other way around if you want. That's what I'm going to do right now. So I'm back in my developer directory here. And let's say I'm going to create a new directory, Git and GitHub intro for the IT professional. Let's go there. And it's just a normal Windows folder. You see, there is no fancy Gitified prompt. It's just a normal directory, empty. In this case, you want to, let's say, upgrade this directory to be a Git source control repository. And you can do that by issuing the command git init. Initiate a new directory or a new repository in this location. And then you will see automatically we have a new main branch created with no changes because we don't have anything available yet. By default, if you install Git, it will, I think, if I'm not mistaken, it will still say master, but the general consensus nowadays in the community is to replace this master branch by the word main branch. So that's what I did. If you want to make sure there's an there are some Git properties that you can change to make sure that your initial branch is called main and not master, and that's what I did on my machine. Right, so yeah, let's maybe do something else. Let's open this directory in Visual Studio Code, which you can do by typing code and then dot, and then Visual Studio Code will open. And as I said, Visual Studio Code has nice integration with Git. It will take a few seconds before it's initialized. We basically see the empty directory here, and on this side of the screen it says main. We are in the main branch, so it automatically recognizes that. Let's put a file here. Let's do a README file. Again, doesn't really matter what kind of file it is. Markdown. Let's put a header here. Welcome to the webinar. It's always fun to type in front of a live audience. Welcome to the webinar. Right, this is one file. Visual Studio Code immediately recognizes that we made one change here. So if you click here, this is the source control. It says, oh, you've got a pending change, which we can add, like we did in the command line, and which we can then commit later on to the repository. Let's do that in the command line. That's good learning exercise. So I refreshed the screen, and the prompt again has changed. We added one file. Again, if you're unsure, Git status will tell you we have an untracked file. That means that Git recognized there is a file there, but it doesn't know what to do with it. So if you need to include that in your repository, you need to add it. Git add. We want to add everything that is untracked right now. It's added, all right, and now we still need to commit it. Let's use this message, git commit, with a message some testing. All right, so we added one file, one insertion, and we added the README file to the source control. It will take some time before Visual Studio Code will realize what I just did, a few seconds maybe, but that's about it. So if we do git log or git ref log, that's another way to do that. We committed one file to the source control. If I go back to Visual Studio, yeah, it realized that I changed something. So that works quite well. So now you're working on your local repository, and if that's all what you need, that's just fine. You don't have to use GitHub. You can just work on your own local source control system, find a way to back up all this, and you might be fine. But the real power in using the system is, of course, using a central repository like GitHub, so you can contribute your code or you can share your code with other people. What you can do right now is you can create a GitHub repository from the command prompt, and that can you do with the GitHub CLI. So if you say GitHub repo create, and of course the authentication bits I've already done by me, GitHub repo create, and it will ask you the same kind of questions that the GitHub website did. So repository name, that's okay, just enter. Description, we don't need that right now. Is it public, private, or internal? Public is fine. And then it says, okay, do I need to add a Git remote to your repository? That means that we're not only creating a remote Git repository, but we're also telling our local repository that we initialized to use that repository as a remote. And the origin here is just a label. So that basically means, do you intend to use GitHub as the origin where the eventual master version of the code will end up? And that's usually what you want to do. So yes, it created the repository and it added a remote. By the way, if you want to see what remotes are available, you can say git remote -v or verbose, and then you can see my local repository on my file system is now connected to this Git repository in the cloud, hosted in GitHub. So if we go back to GitHub, we should have a new repository there. Should be here somewhere, repositories, and then here, GitHub intro IT Pro. But then it's still empty. How is that? We just made a connection. We didn't push our changes to the remote repository. So we say git push, and then you will get an error. because we might have connected both repositories, we still need to tell in which branch our code will have to end up, because we don't have a branch yet in the remote repository. But that's Git. It tells you exactly what you need to do. We want to push, and we want to push it to origin, which is GitHub, and we want to let it end up in the main branch. So you can just, if you want, copy this, git push set upstream origin main, and it will upload everything to GitHub, and we are green again. And you have, in this case, even a little GitHub icon so that you know that you're working with a remote GitHub branch. Let's refresh. So welcome to the webinar, and we are on GitHub. So that's quite cool. In the few minutes that are left, I want to show you what the basic workflow is to contribute back to open source and to issue a pull request. What we're going to do is I'm using a tool called Winget. I don't know if you're already familiar with Winget. Winget is a new package manager from Microsoft, which you can use to install software on your PC. You can say Winget install Spotify, for example, or Winget install Azure CLI or PowerToys or whatever. Now, the information about these packages is kept in a central GitHub repository, which you can also contribute to. And that repository is called Winget Packages. So it's just another GitHub repository owned by Microsoft, doesn't really matter, which contains the manifests or the parameters that you need to install certain pieces of software. So the way of working is more or less the same, but one exception is that if you want to contribute back to open source, the general idea is that you have to fork the repository. So this code is living at Microsoft in this repository, but you have a button here which says fork, and then you are creating a copy of that repository in your own account, which is what we're going to do now. It will take just a few seconds, again, because we are actually branching. That's why it's so fast. Even if it's a really large repository, it's really fast, and that's the power of Git. So we're no longer in Microsoft Winget packages, we're in Thomas Vochten Winget packages. So what you can do now, I've got a piece of software for a microphone that I'm not using right now from Elgato, which has a new version available. And I want to contribute back this version, so when people want to install this software, they have the latest version. So if you want to contribute anything to a certain repository, after you created a fork, again, you clone something to your local PC, and this time we're going to use the GitHub command line interface. Let's go to my Windows machine. We just paste this in, GitHub repo clone Thomas Vochten Winget packages. It'll take some time because it's a few files. It will download everything. Hopefully it will not take that long. And if we've done that, the general idea is that you will create a separate branch for your change. And if you committed that branch to your own repository in GitHub, you will be able to issue a pull request to Microsoft to include that change inside of their central repository. And of course, during a demo, it's taking a little bit longer than anticipated. Bear with me. Right. Let's go to the directory. What is in this directory and in this repository doesn't really matter this time. What you need to know is that these packages are defined through a certain manifest, and they all live in the manifests folder. So, before we do so, we have to create a branch, and that's what you really need to do. So git branch, and you give your branch a name. In my case, I'm contributing back something for the Elgato Wavelink software. So I say git branch, and it will create this branch locally on this repository, and then I have to switch to this branch, and that's something you do with git checkout, and then you'll see the prompt changing. We're now in my local repository in a separate branch. Let's open with Explorer this branch, and then you will get all these files. Like I said, it doesn't really matter where we go now, but I just want to show you how you can contribute something. It's in the Elgato folder, which is hopefully here, and I want to contribute to Wavelink. Yep, and there's a few versions here, but I prepared another version of these files. This one, let's copy that in. I'm taking a few shortcuts right now, of course, because you don't want to see me typing all this stuff. And it contains a few files, and those files contain references to the installation. Let's enter, and Git will detect, oh, we've got, there is something happens. Yeah, again, we have untracked files because I just added something. So we're going to add everything. We're adding it to this branch. We're committing. It's always the same, git add, git commit, and you give it a certain description. It ends up, the change is incorporated into your local repository, and then you still need to do a git push. And again, the same error, of course, it's always the same. We want to also create this branch in my GitHub repository. And again, GitHub is very helpful. It will tell you, and it's okay. If we now switch back to the GitHub website, you see that it already refreshed. It says, Elgato Wavelink had recent pushes less than a minute ago. All right. So what that means is I pushed my changes to my personal copy of Winget packages. And GitHub is very helpful. You can click the compare and pull request button. Now, most of these community initiatives have a certain way of working. In this case, they want me to state that I did all the validation that is needed, that I tested it out, which I did yesterday. So it's basically an extra message, and then you create your pull request. That's it. Now, I can't show you anything further now because now someone from Microsoft is going to review my changes, and with a little bit of luck, in a few hours, my change will be incorporated into the Microsoft Winget packages folder, and people tomorrow probably can install the latest version of this software by using Winget. So that, in a nutshell, that was how you can contribute back to the world. So the typical open source contribution workflow: fork the repo you want to contribute to, create a branch for your change. So don't work in the master or in the main branch, create a different branch, make and test your changes. I just copied something in, create a pull request after you've pushed it to the remote repository, and that's it. And then you wait for the pull request to be accepted, and then your version of the code or my additional files will get integrated into the main repository. And then last but not least, it's optional. You can remove your fork that you created for that change, and that's it. Very important, as a final message, I would say, is learn about pull request etiquette. Every community repository has its own way of working, or has its own format or way of working, or doing things in a certain way. Also, don't do stuff like downloading cloning PowerShell scripts and then changing all the formatting, for example, and pushing it back because you think it's cleaner, stuff like that. Don't do that. So be aware of the etiquette that is valid for that repository. Some key takeaways before we go to the questions. So getting started with Git is relatively simple, but it can be quite complex if you go beyond the basics. But there are many interesting resources that can help you. Using the command line is probably the best way to get started with Git, but don't forget there are other tools like Visual Studio Code or GitHub Desktop that provide a more graphical user interface. And it already says so in the graphic on the below the screen. Commit, push, and pull as often as you can to make sure that you're always working with the latest version. And I would urge you to play around a little bit with Git before you actually contribute to open source, but absolutely don't stop there with your own scripts and your own files. Try to find an interesting project to contribute to, and you will help the community a great deal. All right, a little bit over time. I want to thank you for your attention. If you've got any questions afterwards, feel free to reach out to me. But I suppose people have already asked some questions in the chat, maybe.
Thanks for a great presentation, Thomas. Yes, we will now start the questions and answers part. And should you wish to ask a question, please type it into the questions window now. We're pretty much out of time, Thomas, so I'm just going to take one or two questions, if that's okay, and you have your contact details there on screen, so that's great as well. Okay, one question here. how would you push specific code files rather than all files?
Yes, and that's the way you make atomic changes when I talked about staging. So when you issue the git add command, you are choosing deliberately which files you want to add in a certain commit. So let's say you changed 4 files and you only want to commit 2 to the source control, you only add those files, commit them, and maybe later on commit the extra files. So using the git add command, you can pick and choose which exact files you want to include into source control. In a nutshell.
Super. Is there a capacity to distribute executables to multiple machines, as in production?
The source control system itself will not do anything actively, but you can tie into other systems like GitHub Actions, which is something I haven't talked about, which offers automation capabilities. So for example, each time you check in something or you create a new version of your PowerShell code, GitHub Actions can make sure that it's, for example, deployed to a specific set of machines, or something else is done, a certain workflow is started. That would be the first thing to look at.
Brilliant. On behalf of the ESPC community, thank you, Thomas, for taking the time today to complete this webinar. We really appreciate it.
All right. Thank you very much. It was my pleasure. Thanks for having me.
Brilliant. Okay, everybody, that is the end of today's webinar. Thank you for joining us today. And a big thank you to Thomas Fochin for his time. Don't forget to check out further upcoming webinars at sharepointeurope.com/webinars. Okay, everybody, that is it for today. Take care and goodbye.